For years, there's been one board that's pretty much the go-to starting point for makers, for students, for tinkers everywhere, the Arduino Uno. But let's face it, our projects are getting way more ambitious, and the hardware really needs to keep up. So today, we're going to do a deep dive into its successor, the Uno R4 Wi-Fi, and see just how big of a leap this next generation actually is.
Man, it is really hard to overstate the impact that Arduino has had. This open source platform completely democratized electronics, right? It made it accessible for literally anyone with an idea. It's the foundation for countless inventions, from the simplest little blinking LEDs all the way to complex robotics. It has truly shaped the maker movement as we know it today.
All right, so here's our game plan. We're going to start with a legacy of the classic Uno, where it all began. Then we'll dig into why an upgrade was so necessary. And then we get to the main event, a really detailed look at the new Uno R4 Wi-Fi's power, its features, and of course, a final showdown against the original. For more than a decade, the Arduino Uno R3 has just been this absolute workhorse of the electronics world. It's built around that classic 8-bit 18-mega 328p microcontroller, and its simplicity, its robustness, that's what made it the perfect tool for learning and for prototyping. It is, without a doubt, an icon. But, times change. Modern projects have evolved. We're talking about things like cloud connectivity and way more complex processing. The rise of the Internet of Things, the demand for richer user interfaces, all of that started to really push the limits of that classic 8-bit architecture. The community needed something more. Look, let's be real. An 8-bit processor running at 16 megahertz with just 2 kilobytes of RAM, it's fantastic for a ton of tasks. But when you want to connect to a Wi-Fi network, process sensor data in real time, and run a graphical display all at the same time, well, you're going to hit a wall. The need for more speed, more memory, and built-in connectivity just became impossible to ignore. And this is Arduino's answer. The Uno R4 Wi-Fi is the fourth major revision of the board, and wow, it represents a monumental shift. This is the very first Uno to be built around a powerful 32-bit microcontroller. It really brings the Uno platform squarely into the modern era of computing. So you look at it, and right away, it feels familiar, which is great. It's got the same footprint, the same pin layout, and it still runs on 5 volts, just like the R3. That's fantastic for backward compatibility. But don't let that fool you. Under the hood, this board is a completely different beast. Okay, now when you dig into this block diagram, you find something super interesting. The R4 Wi-Fi basically has 2 brains. The main processor is a powerful Renesas RA4M1 that handles all the core tasks and runs your code. But then it also has a second chip, the famous Espressif ESP32-S3, and its entire job is to handle Wi-Fi and Bluetooth. This division of labor is just incredibly efficient. So let's get into the nitty-gritty. Let's talk numbers. The jump from the R3 to the R4 isn't just some small, incremental step. It is a giant leap in processing power and memory. This is where you really start to see the advantages of that new 32-bit architecture. First off, speed. The new Renesas chip zips along at 48 megahertz. That's a full 3 times faster than the R3's 16 megahertz. What does that mean for you? Well, it means your code for something like a self-balancing robot can run its calculations way faster, making it far more stable and responsive. Okay, this next one is a huge deal. The R4 Wi-Fi packs 32 kilobytes of SRAM. That's the memory your program uses for variables while it's running. Yeah, you heard that right. That is 16 times more than the 2 kilobytes on the R3. This just blows the doors open for projects that were totally impossible on an Uno before, like handling big data files from a web API or creating complex lighting patterns. And what about the space for your actual code? Well, the flash memory has been boosted by 8 times, going from 32 kilobytes to a whopping 256 kilobytes. So you can load up your project with all kinds of complex libraries for displays, sensors, networking, and you never have to worry about running out of room. And really, all of this comes down to that crucial shift from an 8-bit to a 32-bit processor. Think of it like this. It's like upgrading from a basic, old-school calculator that can only handle small numbers to a modern computer that can process complex equations without even breaking a sweat. The ARM Cortex M4 core can chew through larger chunks of data far more efficiently, and that's the foundation for all these performance gains. But listen, the R4 Wi-Fi isn't just about raw power.
It comes packed with a ton of new built-in features that completely change the kinds of projects you can build right out of the box, especially when you're talking about IoT and interactive displays. So the biggest thing right out of the gate is connectivity. Thanks to that dedicated ESP32-S3 chip, you get Wi-Fi and Bluetooth Low Energy baked right in. No more clumsy shields or external modules. It's got a built-in antenna, and it's ready to connect your project to the internet or your smartphone in just a few minutes. And then there's this really cool, really unique feature you can't miss: a 12 by 8 grid of red LEDs right on the face of the board. This thing is fantastic for getting instant visual feedback. You can create scrolling text, you can display data from a sensor, or even code up some simple games, all without adding a single extra component. This is an absolute game changer for getting projects up and running fast. The Qwiic connector gives you a simple plug-and-play way to add sensors and other modules using the I2C protocol. All that really is a simple system that lets different parts talk to each other. It totally eliminates the need for a breadboard and soldering for so many common components.
And believe it or not, the list of upgrades just keeps going. There's a built-in real-time clock, which is perfect for data logging. You get a higher resolution 14-bit analog-to-digital converter, so your DIY weather station will be that much more precise. There's a CAN bus, which opens the door to projects that talk to car systems, and a true digital-to-analog converter, which is essential for things like audio projects. Whew. Okay, that was a lot of new features. So let's put it all side by side. Let's do a direct head-to-head comparison to really appreciate the evolution from the classic Uno R3 to the brand new Uno R4 Wi-Fi. I mean, look at this table. It really says it all, doesn't it? We're going from 8-bit to 32-bit, we're gaining Wi-Fi and Bluetooth, clock speed triples, SRAM and flash memory are just orders of magnitude larger, the analog precision is higher, the input voltage range is wider, and finally, that old USB-B connector is replaced with a modern USB-C. In every single category, it's a massive, massive upgrade. And here's maybe the best part of all this. Despite all those massive internal changes, Arduino made sure to maintain compatibility. The form factor, the pinout, the 5-volt logic level, it's all the same. That means the huge ecosystem of existing shields and hardware that was designed for the Uno R3 should just work seamlessly with the new R4. So, what does this all boil down to? What's the big takeaway? The Uno R4 Wi-Fi takes that simplicity and accessibility that made the original Uno a legend and slams it together with the power, the memory, and the connectivity that we need for today's ambitious projects. It's just more powerful, more connected, and it gives you more creative tools right on the board. This is a true next-generation board that opens up a whole new universe of possibilities for makers of all skill levels, which really just leaves one question left for you to answer. With all this new capability right at your fingertips, what are you going to make?